Yeah,
So I'm good.
I've started
We
the
can
recording.
start.
Yeah, yeah. Now you can start it. I'll mute myself, and you can start teaching, sir.
Okay.
Okay. Thank you very much.
Gaurav, one question before I start.
Yeah.
So I'm assuming you guys are familiar or that attendee team will be familiar with the basic concepts. Like I would like to know what kind of audience I'm facing when
Yeah.
I'm giving the tutorials.
Okay. So, sir, basically the audience that you will be facing will have a general idea. Okay. Basically,
Like are they familiar
they
with
have
SAP
gone through.
BW?
I'm not so sure about it. It depends to student to student. Basically, sir, this audience will be having two type of courses. One is self-paced as well, along with the online. Okay, so they have an access
Okay.
to our on our website to all the trainings videos. Okay, so
Okay.
most of them have gone through it, I guess. Okay, so they already maybe they have some idea. Okay, or you can have a conversation in the first lecture with them, and you will be able to find out like what kind of audience is it.
Okay.
Okay, sir.
Ah, sure.
Okay, yeah, you can start it, sir.
Okay. So just I'm starting. Thank you, Gaurav.
Thank you, sir. Thank you.
So here we have agenda which we include introduction to the SAP HANA, SAP in storage, in memory storage in SAP HANA compared to the SAP BW. So it's a very brief PPT, so I will start with it. So first of all, HANA, what we think about HANA? SAP HANA is high analytic appliance, which as a name suggests, it is used for high analytical processing. As you know, the world is going on a large pace. We have lots of many transactions in each day, so it requires large amount of data to be processed. So our basic legacy systems, all our old system will not be sufficient to provide all the required data. So as we are familiar with SAP BW that we are using currently is now facing some issues. Like it is not provide the required amount of uh, basically what we can say required amount of responses that we need. It's getting slower day by day. We have large data that need to be processed, and each and every query are getting more and more complex day by day. We need to get the trends and we need to get every application. So these days we are demanding a better processing analytic engine that world can access. So here comes the HANA. HANA, this is the definition: high performance analytical appliance software and hardware. So HANA has basically basic characteristics that makes it so special. Then that defines why we use HANA. So HANA goes around its specific characteristics like it's in memory server, and it uses RDBMS. It's column oriented and it's object oriented. These characteristics makes HANA so special. So I'm gonna discuss all the things like what do you mean by in memory, RDBMS, column-oriented approach, and object-oriented approach. So it's a very, I'm gonna give you a very abstract view so that we can get to know how the system is flowing. First of all, we will start with what is in-memory system. So in-memory defines that the database is stored in HANA procedures. HANA engine is basically stored in the memory itself. As we see, our classical SAP BW system are hardware oriented. All the relation databases are stored in the hard disk, which involves additional time that we have to use for paging and requesting the data, then extracting data from the hard disk and getting it to the main memory, which I suppose it's amount to about 90% of the processing time. So HANA cut shorts it. It directly fetches the data from the main memory. We all are computer students and we are much familiar with that. That main memory uses much lesser time than using a secondary memory in action. So here we have a hard disk database on which we have a RAM. So this hard disk is as suppose as the base where the relational information is stored. So this information is kept as in view, or we are going to discuss view as well. What's in view? So we store aggregates, views, and com- uh, such kind of information storage in the RAM, which HANA is going to use for accessing and providing data for the various queries and transactional logics that we need. So second thing that I will talk about HANA characteristics will be a column-oriented approach. So this approach is basically used to increase the accessing and reading ability of the database. Earlier we had row-oriented approach. That was good for a smaller database. Like if you are reading a smaller chunk of data, then you can go with the row-oriented approach, in which a row ID is associated with all the rows. And if you want to read some data, we used to go through the row IDs, which get all the characteristic attribute that we need. Secondly, now in column-oriented approach, we associate the column IDs with each and every unit in the column. So this way, we are segregating the data on the basis of column. When an query came, it easily can extract, like for example, if you have a query named as select star from table name employee, where employee name is John. So all the figures, all the values which have all the characteristics that are all the data in the table that has the entity as John, as the value as John, will have the same column ID. So this is gonna capture all the rows and all the required data in just one search. So we don't have to work on it much. So this highly efficiently reduces the processing and accessing the data. Second thing, we will go by object oriented. So this is a very common approach in these days, because now we are not we are going on the bottom to up approach that makes object as the basic reference variable. So we go by each, we keep the object like employee and candidate, personal number, as each employee a characteristics figure, and we can use them as the basic building objects uh, of our entire architecture. This helps us to access the information and get a better view about the system. And later on, if we want to add more functionalities, this object-oriented approach helps us to do that. So our database is here. It's written that HANA database is in the memory. So I'm pretty much sure you understand what do you mean by the database is in the memory, as I discussed in my first point, that HANA is an in-memory system. So we have two types of processings. One is OLTP and second one is OLAP. OLTP is online transactional processing, and second one goes for online analytic processing. So these are two basic processings that we are using nowadays, and they are completely different. OLTP includes the daily transactions that we have, and OLAP includes is historical kind of transactions that we use for forecasting how our future transactions are going to go, and anything that's related to historical reporting will be done on the OLAP. So now we'll talk about OLTP. That's online transaction processing. In this processing, we include all the daily basis transactions that we do. It's more read and write oriented. It involves fast processing. It has frequent access to the database, where we insert, update, and delete data on the very frequent basis. So if we suppose, I'll take an example of a big bazaar. You're going to big bazaar and you're purchasing something. So the system will record your transaction and send it to the database, and it is maintained on the daily basis. It is not preferable to keep a transaction or a large amount of data, or last few weeks of data in the transactional processing. Still, we can keep it for up to a month. That it depends on the client-specific requirements, how we need to keep the data in the OLTP servers. So we have an option of creating reports and queries in OLTP. So this is a bit more complex thing that we can discuss later in this presentation if the time permits. So next is, as I mentioned, we have second type of processing, that is OLAP. OLAP is online analytical processing. So here we have, these processing are basically meant for read transaction. These are not updated on regular basis. These are frequently accessed for only read purpose. These are not meant for frequent write and update purpose. In this, we store transactional data, historical transactional data. These we use for forecasting and other processes that we need. So I will move on to the next slide because it includes many other things like in OLAP we have much cube generations and other fields as well. How we are reporting crystal reports and Webby report, Webby report, reporting, accessing the information, and creating online analytical types of objects that we can create. We have all these tools enabled for OLAP, which provides reporting and considering the facts we need. So here we have SAP BW. As you're familiar with the technology, it is SAP Business Warehouse. Warehouse is a place. It's not a place. It's a storage area where we keep a large amount of data in smaller packets, like in form of data marts and data structures in a warehouse, and it stores the transaction and all of data in this. So SAP BW includes this read and write processing like any other analytical process in any other processing engine, like any other processing engine. So this is on a completely different league than OLTP and OLAP. It's basically used as in using the ETL process. This SAP BW is now in market. People are using this. It's a SAP uh, SAP provided edition where we use it for transaction extraction, transfer, and loading of the data. So it's a very vast topic. If we include this, we have transformations, creation of InfoCube, transformation of InfoCubes, and all that. We can mention any kind of report generation in it as well. We have multi-providers, aggregates, BWAs, BIAs. So we have all these options available in SAP BW. So here we have SAP in-memory strategy, which will say, which this diagram is depicting, as we have already discussed. It's having intelligent analysis and intelligent analysis database. So we have multiple types of database like legacy database and all others. So for if we are talking about SAP HANA, so we will consider our database discussion to only relational databases. So relational databases are using basic architecture where we have dimension table, where we are including dimensional table, fact tables, and which provide the basic architecture. In this, in context of relational database, if we talk about, we have some other concepts that expands its curiosity. Hello. So
Hello, hello.
yeah,
Yeah, I
sorry.
just
I
mentioned.
thought
Yeah,
I broke up.
yeah.
Sorry.
Sir, I guess
So
that will
we
be
are
fine.
talking about,
Not an issue, I guess.
okay.
Hello.
So we'll talk about the next slide. So I was discussing about star schemas and extended star schemas that are very important these days because these are not just concepts now, because it's forming the very for in this category, database category. So we will have to look into deep dive, we have to gain a deep dive knowledge about extended star schemas because they are extensively used in every database system we are using. So SAP BW with BWA, that's BW aggregates. What do you mean by aggregates? So aggregate is basically a stored view or a stored aggregate that we keep as a copy of the actual data, but with some restrictions on it. Like we are extracting a report, so we are extracting a report. It's a very complex report, so it's a frequent record. We need to access it many times in a day, or many times a week, we can say. So every time we'll have to go to the SAP BW system databases from where the SAP BW will fetch the records and apply the logics and then create other views on it, and then we are extracting that report. It's time consuming. So what we do, we use these aggregates as a basic architecture. So we keep these aggregates as stored data where it is stored in a higher complex form. Like we can have this as an view created on an actual database. So these views are stored in on another server. So for BWAs, we use a copy of the actual data. So with where we are applying some logic. So next time when BW report is need to be run, a complex report need to be done, it can directly go to the BW aggregate that's on a different server than the relation database. So it will directly go there, fetch the already created aggregate, and it can generate a report in much lesser time. So this helps to reduce the time and greatly improves the performance of the system. So if we are talking about BWAs, we have BIAs also. So this way we can create the index, and that helps us to uh, get more information and reduce the time to create and fetch the information required for a report processing. So actually this all HANA and all BW, these all we talk about are basically for transaction and loading of the data and generating a required report on it. So if we are talking about reports, so we have multiple types of report that we can also discuss: crystal report, dashboards, ordinal standard reports. So we have all these topics that we can cover in this. So next slide says SAP HANA compared to BWA. So as we have already discussed, SAP HANA, as it is depicting here, SAP HANA is a DB in-memory IMCE. So it's a very large in-memory system. So if we are fetching a report, we are directly accessing the in-memory, and we are directly going to the relation database, and we are fetching the data. So here the data can be filled from SAP BW system itself. So that we call usually as an SAP BW on HANA. So if we have a large memory, so here we
Hello,
see
Jasmeet sir.
they are depicting.
Hello.
Yeah,
Sorry to
yeah.
disturb you, sir. I think
Okay,
that will be completely fine. Not an issue. I've recorded the session. Okay.
okay.
I'll show it to my senior. Uh, and I guess we can do this by tomorrow morning. In first half, I can let you know, sir. Okay, about the what
Okay,
will be the
sure.
exact
Because
timing and each and everything.
uh,
So, will
sure, sure.
I'll be getting any of your contact number, or should I contact Gurpreet only? Gurpreet sir?
You can get my contact number from Gurpreet. He can share the same number with you.
Uh,
So Gaurav, I'd like to mention one thing.
yeah.
I have my system, non-SAP system, going on cloud, so I can be pretty much occupied as I'm today.
Hmm.
So just give me a prior intimation, like the session is gonna start by